atmospheric pressure detectors. They measure the pressure of the Earth. One of the surprises is the reason is coverage is so bad that they need video records of accidents. So there are thousands of these cameras scattered in Russian cities, and many of them captured the views of this object. So here is the cloud that was left by this thing as it streaked into our atmosphere and did not hit, it disrupted in the atmosphere. And this beautiful cloud unfortunately drew many people out onto the street. About 2 minutes after the impact event, the shock wave of its passage through the atmosphere hit the city, busted glass, all over the place. This is the entry to one of their large theaters. This is now one of the largest casualty rates of an impact event simply because of breaking glass that hurt people that were out on the streets because of hearing something had happened, but the shock wave hadn't reached the city yet. Well, as Cheryl mentioned, the reason we are celebrating Asteroid Day today goes back to 1908 on this same date. One of these same kind of events happened over a very unpopulated part of the Siberian tundra. And that blast knocked down the forest over a large area. There were several scientists who tried to get there. It was so difficult to get there, it actually took years for the scientists to make it. When they got to the location, they were going to look for a crater, but again, this exploded in the air, and the blast wave knocked trees down, like in the upper left, but right under the place where the detonation happened, the trees are still standing. All of their branches and leaves are stripped off, but it looked like a telephone pole forest. Well, these air blasts are something that we still need to think about. On the left are views from Venus. These are radar images, but they show the effects of this shock wave in an atmosphere. The object has been disrupted by entering the atmosphere, but the blast reaches the surface. And what we don't want to happen is one of those occurrences over a city. On the right is an artist's view of what if one of these air blasts happened right over a major city like Los Angeles. That is a concern that even without creating a hole in the ground, we need to be worried about these objects. Now, one of the most famous places, at least here in the U.S., to visit the result of an impact is something called Meteor Crater in Arizona. It's one of the youngest features preserved here on the Earth. Why doesn't the Earth look like the moon with all of those craters? We think that the same barrage happened, but Earth's geology and its active weathering system has erased many of those things. This feature happened about 40 or so thousand years ago, and that is young enough that it has not been erased by erosion, and is now the site of a lot of public visiting, but also scientists. I went there when I was a graduate student to learn about impact cratering. Now, a little bit closer to home, for those of you who are from the DC area, you might not realize it, but a very large impact crater is not that far away. The map shows the two rims of this crater centered around the Chesapeake Bay. And so we refer to it as the Chesapeake Bay impact. But surprisingly, this happened when this part of the continent was underwater. So let's go ahead and go forward. That colored map shows where the shoreline was. That white line is where the ocean front was 13 million years ago, and the impact was into the shallow continental shelf. Well, that actually was another contributor to a problem. So the diagrams are computer-generated views of what happens in these impacts. The upper left is only 5 seconds after the impact. Material is still being thrown out, and the light gray is water, the ocean water. The darker gray is the rock beneath it. 35 seconds after it, the center of the floor of the crater is rebounding, and that's what made the hill in the center of Tycho on the moon. So that rebound happens in less than a minute, and yet these features can be, the size of mountains. So this is geology on a very fast time scale. The lower diagrams show the water retreating from the impact, and then up to 5 minutes later, it finally came back and reoccupied the crater. And we don't see a crater today because it is about a kilometer beneath the surface of the ocean. And it's only through drill cores that we know that the crater is there. Now, an even bigger event, very similar to what I just described, happened over the Yucatan area of Mexico, and this led to the demise of the dinosaurs 65 million years ago. So the colorful map is gravity, looking at how the rocks are distributed in their densities, and those circular structures are the rings of this impact. This is a very large feature, but it also, just like the Chesapeake area, it impacted into a continental shelf. Unfortunately for the dinosaurs, it impacted into a carbonate rock, and without going into the great details of that, the impactor disrupted the carbonate and created an acid rain that contributed to the death and destruction brought on by this impact event. Fortunately, these size of impacts are pretty uncommon, and this one, 65 million years ago, should not happen for hundreds of millions of years. There have been even bigger impacts, though, in Earth's history. Giant is really not even the word to apply to this. The artist's view at the upper left is the early Earth and an object the size of Mars slammed into it and ejected much of the mantle of the Earth into orbit around the forming Earth. Well, scientists refer to this now as the Big Whack, informally, rather than the Big Bang. And our moon formed out of the material that was the result of this enormous impact. But it's so early that there is no geologic record of this on either the moon or the Earth now. Well, I'll move on to some asteroids, and you may not see them too well, but on the right side are some of the asteroids visited by spacecraft. On the left is a close-up view of one of the larger ones, because the spacecraft Dawn orbited this asteroid for a year, giving us information about it. And here's another view. This very odd-shaped asteroid is a result of an enormous impact. So the three views in the upper right, two are Hubble Space Telescope images, one of which is a mathematical model of the shape derived from those images, and then the colored view is the topography. That circular depression is an impact almost the size of the object itself. What that means is if the impactor had been even just a slightly bit bigger, it would have completely disrupted the asteroid. So impacts can not only make holes, if they are big enough, they can completely break up objects. Now, nature does impacts just fine on its own, but we as humans have done our own. Here is the Deep Impact mission, where an object was intentionally sent to impact onto a comet nucleus, and the lower right picture is a minute after the impact, so that a following spacecraft took pictures and spectra to give us compositional information of what was thrown out by that impact. So we are generating our own impacts now for the sake of science. And we do it in other ways. So when the astronauts went to the moon, the third stage that carried the astronauts out of Earth orbit towards the moon, for the first missions was just sent into orbit around the sun. Later on, this was the Apollo 14 third stage, was directed to impact the moon because the astronauts on previous landings had left seismographs. This caused the moon to ring like a bell and gave us very important controlled information about the structure of the moon. Now, even today, impacts are still happening, but we are fortunate to have actually witnessed a whole series of them in 1994 when a comet was busted up into several different fragments. So the picture at the bottom are what has been referred to as the string of pearls, all these little fragments of what had been a comet nucleus streaming towards Jupiter, and they make those dark spots that show up in the Hubble Space Telescope images of Jupiter. This didn't make a hole because Jupiter is a gaseous planet, but those spots remained visible for weeks. And I still remember, even though I was out of school, I had my own telescope, and I was just really impressed. I could see spots that hadn't been there the week before, and about 4 weeks later, I could no longer see them. So impacts are still occurring today throughout the solar system. Now, the moons of Jupiter have the whole complex history of their own. We'll just talk about a couple of them. The smallest there, Europa, is just a little bit smaller than our moon. Io is just a little bit bigger. But the two larger ones are mostly icy objects, and they have a record of impact on them. Ganymede, the biggest, is actually the largest moon in the solar system. And here is a picture from the Galileo spacecraft of one of those impact objects. Well, on this icy crust of Ganymede, there are some normal craters like we've seen on the moon, but what's that funny white spot? It has very little relief. Well, it's given the funny name palimpsest, which, if any of you are historians, that refers to a process of writing where the actual ink of the writing is not preserved, but the impression of that writing stays on the paper underneath. That's called a palimpsest. Well, this is a crater that sort of relaxed. It went away, and yet it happened recently enough that we still have record of it in the icy crust of Ganymede. And its neighbor Callisto, only slightly smaller than Ganymede, has, again, even bigger impacts. The sort of white spot is a basin bigger than a single impact crater, and all of the white rings around it are the fractures in this icy crust caused by this very large impact. Jump back to Mercury. We've been sort of looking at the outer solar system. Well, the inner part of the solar system has been impacted just as much as the other things we've been talking about. This is a picture taken by a spacecraft named Messenger that was in orbit around Mercury for about 4 years, collecting a whole variety of interesting information. The bright feature towards the center of the scene, that's one of the more recent impacts. And it is bright because it has not weathered. Now, what do I mean by weather on a planet that has no atmosphere? One of the things that can alter the rocks on objects, particularly those without atmospheres, is the influence of the sun, either the particles coming off of the sun itself in the form of radiation or the gamma rays and sort of very high energy electromagnetic things. All of that can alter the soil and literally make it darker. So impacts are bright until this weathering process has dimmed the apparent brightness of these ejected materials. And we'll terminate here with Tethys. This is one of the moons of Saturn. So the whole range of the solar system has experienced impacts like we've been talking about. This is another icy moon, which means that its crust is completely made of frozen water ice. And the most prominent feature sort of at the upper half of the image there, that's an impact crater comparable to Tycho, like we talked about on the moon, a very prominent rim and a prominent central peak. Again, realize that that peak is the rebound of the crust after the impact, so that these size of craters literally take time to evolve. It's kind of hard to wrap your mind around, but the formation of that crater literally took minutes for the impact to occur, the crust to respond, and all of the ejected material to settle back on the ground. That sounds slow, but it's actually fast geologically. It's slow enough that if we had had a spacecraft out there orbiting, we could have observed this impact process. Well, with that, I'll open it up for questions. And we can either get them from the floor here. Yeah, and if you would please just go over to the microphone, and I'll try and repeat the question for the people online. We're going to start with a question that has come in on Facebook Live when we get the mic going here.
Good. All right, we're going to start with the Facebook Live question from Ken. How big would an object have to be catastrophic on Earth?
Ooh, excellent question. How big does something have to be catastrophic? And that's sort of a complicated answer. Hopefully the pictures I've shown you will help you realize if something hits the ground, that's a bad day right at that impact site. But we have also learned that if it blows up in the atmosphere, that can be a problem right beneath it. So what's the size difference? Let's just talk about Earth initially. Chelyabinsk and Tunguska, both were objects that disrupted in the atmosphere. Why did that happen? This was a rocky object. How do we know that? There were little tiny beads of both of these things that were melted, that fell down to the surface, that have been collected, and they look just like meteorites, asteroid rocks. So that we know it was a rocky body, but it was coming in to denser and denser parts of the atmosphere. And just imagine